So here we will be basically discussing fundamentals of differentiation. I assume that the basic differentiating formulas or the differentiation formulas are very much clear with us as an engineer. For example, let us go through some of them. Like if I say d by dx of x raised to n is nothing but nx to the power n minus 1. What is d by dx of sin x? d by dx of sin x is cos x. Okay, cos x would become minus sin x. Then dy by dx of e raised to x is e raised to x itself. dy by dx or dy by dx of 10x is sec square x. dy by dx or dx of log x is how much? Is 1 by x. Correct. So these are some 10 formula. For example, you can say d by dx of sine inverse x is nothing but 1 upon under root of 1 minus x square. Similarly, if somebody asks you what is d by dx of, let's say, sec x, this will be sec x 10x. So these are some standard results which we have already studied in our earlier standards, right? So based on this, we will solve certain problems. Let's say I'll take a problem. If y is equals to x raised to x raised to x up to infinity, find dy by dx. Now this problem seems to be an infinite loop where we don't understand where to start and how to start. But if you solve this in a very simple manner, we can get the answer very easily. If you keenly observe this, can I say this equation as y is equals to x to the power y? Isn't it? So dy by dx will become what? You can say that, right? But what I want to do is, let us take log on both sides. Why I'm telling you is, it will help us. How? Let us understand. Taking log, it will become log y is equals to y log x, right? Differentiating both sides with respect to x, so it will become what? 1 by y dy by dx is equals to, see, these are two functions. We know how to multiply two functions. Let us say y into dy by dx plus log x into dy by dx, right? So let us rearrange 1 by y minus log x dy by dx is equals to y by x, or dy by dx is equals to y by x upon 1 by y minus log x. You can simplify it if it is available in the option, or you may leave the answer in this format also. Now let us also understand the applications of differentiation. Many a times questions are asked on this. There are 2-3 applications which we can see. First, you can see is dy by dx basically represent the rate of flow, especially in mechanical engineering and civil engineering when you talk about fluid mechanics. So you'll talk about rate of flow. So rate of flow is defined by differentiation, right? Viscosity. So there we use differentiation, right? dy by dx or dy by dt. Second, you can say, for example, velocity. What is velocity? Rate of change of rate of change of displacement, or we call v is nothing but ds by det. Similarly, we say acceleration. Acceleration is nothing but dv by dt. So there is the application, it is used to find the rate of change basically, right? Then you have an application in terms of finding out the maxima and minima value. Maxima and minima value, right? We know we have again started this in earlier standard. Very simple logic. For example, steps. How will you find out? Is first find f dash x for the given function fx. Then put f dash x is equals to 0 to get the maxima or minima points, right? Once you get maxima minima points, let's say x1 x2 are the points. Now how will you say that it is a maxima or a minima, right? That you have to find is very correct. Double derivative. We already know this particular. Find out f double dash of x, right? If f double dash of x is greater than 0, let's say x1, then x1 is a point of minima and minimum value is f of x1. Similarly, if f double dash of, let's say, x2 is less than 0, then x2 is the point of maxima and maximum value is f of x2, right? So what I said was find f dash x, put f dash x equal to 0, find out minima or maxima point. At this minimum maxima point, find f double dash x. If f double dash x is less than 0, point of maxima, greater than 0, point of minima. What if it is equal to 0? If f double dash x3, let's say, is equals to 0, then this is a case of further inspection. Case of further inspection, and we will find out the triple derivative. Fine. We'll talk about this triple derivative later on. First, let us discuss a couple of questions on this. Let's say let us solve a question which came in GATE 2004. Question was the function fx is equals to 2x cube minus 3x square minus 30x 6x plus 2 has its maximum or maxima at options x equal to minus 2 only, x equal to 0 only, x equal to 3 only, or both at x equal to 2, sorry, minus 2 and x equal to 3. So let us start solving it. You have a function 2x cube minus 3x square minus 36x plus 2. First let us find out f dash of x. It will become 6x square minus 6x minus 36. Then I said put f dash x equal to 0. So if you put f dash x equal to 0, which is 6x square minus 6x minus 36 equal to 0. You can also say it is x square minus x minus 6 is equal to 0. So if you split the middle term, you will find x square minus 3x plus 2x minus 6 equal to 0. X common, x minus 3 plus 2 common, x minus 3 is equal to 0. So x equals to minus 2 comma 3. Now what are these? These are points of minima or maximum. See, try to understand what we are trying to do. Let us say that this is your curve, right? Now let me make it a very smooth curve. Let's say this is your curve. Now it is fx. Now by doing f dash x, what we are trying to find out, we are trying to find out the slope. F dash x is nothing but the slope at any instant x, and we are substituting that to be 0. So f dash x 0 means what? I'm talking about this point either, isn't it? Or I'm talking about this point either. Getting my point? This is getting a lighter. I'll use a darker pen. Right? Let's say this point I'm talking about, where f dash of x is 0. F dash of x is 0. Now both point f dash is equal to 0. That means that these 2 points f dash x is 0. I don't know actually that this is a point of minima or maxima. Getting my point? So in order to check that particular thing, what do we have to do? In order to check that particular thing, what we have to do? We have to find f double dash x. You have to find what? F double dash x. Right? So let us find f double dash of x. Right? Fx was what? Sorry, f dash x was 6x square minus 6x minus 36. So this will become 12x minus 12x minus 6. Right? Now need not to put it to be 0. Right? What do you have to check it? F double dash of, let's say, minus 2. So it will become 12 into minus 2 minus 6. So this will be positive or negative? It will be negative. You don't want the value. So if it is negative, it will be less than 0. So minus 2 is a point of maxima. What did you want? You also wanted the point of maxima, isn't it? Let us check it. F double dash of 3 now. f double dash of 3. So it will become how much? 12 into 3 minus 6, which will be a positive value. So 3 is a point of minima. So what will be your answer? Hence, for our question, maxima occurs at x equals to minus 2 only. That is option number E. That's your answer. Clear? Understood? Right? So this is how you can find the questions on maxima and minima. Innumerous amount of questions has been asked on this particular fundamental. You can go through the gate questions. You will find many questions are been asked on this fundamental. So we can easily solve that kind of questions, right? You can find other application of this in terms of finding out equation of tangent, equation of normal, right? So there we can use application of derivatives. Let me give you one example. Finding out equation of tangent to the curve. Derivatives are very important. Many a times we discuss derivative in engineering mathematics and other subjects also. Let us say a function is given to you. Fx is equals to, let's say, 2x square minus 6x, right? And you have to find an equation, you know, find the equation of tangent to the above curve at point 1 comma minus 4. How will we solve this? In the above curve, you have to solve, you have to find an equation of a tangent at a point 1 comma minus 4. Now see, try to understand what is the tangent basically. Geometrically, what is the tangent? It's a parabola, it's a circle, it's a straight line. What is it? It's a straight line. Correct? Now, to draw a straight line or to find the equation of a straight line, what do we want? We want either 2 points, or then we can answer the question in 2-point form, or we want 1 point and 1 slope, isn't it? There have to be 1 point and 1 slope. So how we can do that? Let us say 1 point I have. Slope, can I say it is nothing but the derivative of this curve? Huh? So what is f dash x? Is 4x minus 6. And what is f dash x at point 1 comma minus 4? It will be nothing but 4 minus 6, that is minus 2. So you got the curve M. Now equation of tangent will be nothing but y minus y1 is equals to m times x minus x1, right? So y minus minus 4 is equals to minus 2 times x minus x1. Very simply solve it, you will get the answer. Y plus 4 is equals to minus 2x plus 2, which implies that 2x plus y plus 2 is equals to 0. That is the equation of required tangent. Clear? How to derive this particular type of question. If normal was asked, what you have to do is the normal will be, the slope would become minus 1 by m times, correct? Because normal and tangent are perpendicular to each other. So this is how you can find out the normal, right? So many questions you will find in the gate paper based on this particular fundamental, right? Next heading in this particular unit we will move on to is integral calculus. Integral calculus. We know basically it is integration, just opposite of differentiation. Basic formula goes like x to the power n will become x raised to n plus 1 upon n plus 1. Integration of 1 by x dx would be log x. Sin x integration will become minus cos x. Integration of cos x will become minus sin x, plus sin x, sorry. So this is how we can always derive. These are just opposite to what the formulas which we have for differentiation, right? There are one or two standard results which we can use. For example, integration of 0 to pi by 2 sine to the power nx, or integration 0 to pi by 2 cos to the power nx is written as n minus 1 into n minus 3 into n minus 5 and so on upon n into n minus 2 into n minus 4 into k into k. K is equals to 1 if n is odd, and k is equals to pi by 2 if n is even, right? Similarly, you can also get one more of this kind. Integration of, let us write it down here. Integration of 0 to pi by 2. Limits are very important. Sine to the power mx into cos to the power nx dx is nothing but m minus 1 into m minus 3 and so on into n minus 1 into n minus 3 and so on divided by m plus n into m plus n minus 2 m plus n minus 4 and so on into k, where k is equals to pi by 2 if both m and n are even, and k is equals to 1 otherwise, right? So this is another standard result which we can use. Then we can, when we talk about definite integrals, or when we are talking about integrals with limits, so we can also say that integration between a to b fx can be broken as a to c fx plus c to b fx, where c, you can say this is the point where c is a, it is not necessary, right? So there is area under the curve, right? So if you subdivide the areas, then it is not going to make you much difference there, right? Similarly, if you say f a 0 to a fx can also be written as a to b f of a plus b minus x, standard rule. Similarly, if you say 0 to a fx can be written as 0 to a f of a minus x dx, right? Then if I have minus a to a of x, this becomes 2 0 to a f x for fx is a even function, and this becomes 0 when fx is odd function, right? What are even function? Even functions when f of minus x is equal to fx, right? F of minus x is equal to fx. Clear? Okay. Then before getting to the questions, we'll have one more understanding, that is solving of integration. One could be substitution method, where we substitute sin x is equal to t, and then cos x will become dt and so on, right? One is substitution. Second is integration by parts. Integration by parts. For example, if you have integration of u into v dx, so it is nothing but u into integration of v dx minus integration of derivative of the first into integration of the second, right? So this is integration by parts. And how you select u and v? Selection of u and v, or I would say the first function and second function, is based on Lie rule. Lie rule. Where L is log functions, I are inverse, A is algebraic, T and E. T is trigonometric and E is exponential. So this is the rule which we'll be using for by parts, right? For example, let us say evaluate integration x e raised to x dx. Now can I see two functions? One is algebraic, one is exponential. So this is the first, this is the second. So how will we solve this? We'll say I is nothing but first function into derivative of the other minus derivative of differentiation of the first into, sorry, derivative of the first, that is 1, into integration of the other. So it is nothing but x e raised to x minus e raised to x. So you can take e raised to x common, it is x minus 1. That's your answer, right? Now for these types of function, let me give you a small shortcut here. Shortcut. What is the shortcut? Let us understand. He said integration of x e raised to x. Directly what you write is e raised to x into this function x minus derivative of, what is the derivative of x? 1. That's it. You can check your answer. Let me give you one more example. Let's say integration of x square e to rest. What you said was put e raised to x into this, that is x square, minus derivative of this is 2x, plus alternate minus plus it will go. Derivative of this will be 2. That's it. You can solve it. Let's say x to the power 3 e raised to x. What it should be? E raised to x into, put this function x cube minus derivative of this, that is 3x square, plus derivative of this will become 6x, derivative of this minus 6. That's it. Single liner, you will get the answer. Clear? Supposedly you have x cube, or let's say x square e raised to 2a 2x. E also has a power. So it is nothing but e raised to 2x. It is x square by 2 plus, sorry, not plus. The numerator will be same. X square minus 2x by 2 square plus 2. Clear? You can check it if you want. Let us say this is u, this is v. So I will do first function into derivative, oh sorry, integration of the other. Right? Let us, I'll show you how to solve this. First function into integration of the other minus derivative of the first into integration of the other. Right? Then we solve it. What you'll get? E raised to 2x integration is e raised to 2x by 2. And again we'll use by parts in the second part. When we'll solve it, you'll get something like this. So it will be something like this, right? So which is very much similar. So these are some small shortcuts which you can sometimes use and get your answers. Right? Let us solve some gate problems on this integrals calculus. Let us say you have a function, find I, which is integral 0 to pi by 2 sine raised to 3x cos raised to 5x dx. Now this is of the format which we can use directly. It is of the format 0 to pi by 2 sine raised to mx into cos raised to nx dx. Remember? So it was m minus 1 into m minus 3 and so on into n minus 1 into n minus 3 and so on, divided by m plus n into m plus n minus 2 and so on into k. So in this you'll say I is nothing but m minus 1 into m minus 3 will give you 0 into n minus 1 into n minus 3 upon m plus n into m plus n minus 2 into m plus n minus 4 into m plus n minus 6 into k would be 1 because both are in fact odd. So it is nothing but 2 into 4 into 2 upon 8 into 6 into 4 into 2. This get cancels out. This again gets cancels out with 3. So it is 1 upon 24. That's your answer. Clear? So these are some certain questions which can be easily solved in your paper sometimes. Right? Let us say another example, let us take evaluate p is equals to 0 to 1 x e raised to x dx. This was GATE 2010. So we have just seen this, right? Islets. Directly can I write this? Integration 0 to 1 x e raised to x can be written as integration. Yeah, solve the integration, right? I can directly write it down. How? E raised to x into x minus 1. Very simply. And the limits will put 0 to 1. So when I put 1, e raised to 1 into 1 minus 1 minus. When I put 0, so it is e raised to 0 into 0 minus 1. So this part is not going to give you anything. This will become 0 minus minus 1. So ultimately it will become 1. That's your answer. Clear? How to solve these kind of problems, right? Let us take one more example. Let's say evaluate integration 0 to pi by 2 cos x upon under root of cos x plus sin x. Now it becomes very difficult to handle these under roots, sometimes. So be careful. Typical method to solve this particular thing. Let us say I we represent this under root of cos x upon under root of cos x plus under root of sin x. We'll use a property here. What is the property? Property says if you have a integration 0 to a fx is equals to, it is nothing but 0 to a f of a minus x. We'll use this property. Can we use that? Yes, we can. How to use this? Let us understand. So I will become, this is equation number 1. Here I will become 0 to pi by 2 under root of cos of pi by 2 minus x upon under root of cos of pi by 2 minus x plus under root of sine of pi by 2 minus x. Isn't it? What is cos pi by 2 minus x? It is sin x. So I convert it to under root of sin x upon under root of sin x plus, can I say this will become cos x? Pi by 2 minus x will be in the first quadrant only. So first quadrant all are positive. Let us say this is equation number 2. Now if I add 1 and 2, so what I'll get in the left hand side? I'll get I plus I, that is 2i. And what is the integration will give you? I'll combine the integration, it will say under root of cos x because the denominator is the same, plus under root of sin x. I'm directly writing it for under root of cos x plus under root of sin x. Can we? Yes. So can I say that 2i is nothing but integration of 0 to pi by 2 dx, or integration of 1 will be x, or you can say it is nothing but pi by 2 minus 0 2i. So I is nothing but pi by 4. That's your answer. This is what you want. Clear? So this is how basically you can get your answers at times. So again, numerous amount of questions you can solve. There are a lot of questions which can be framed and which can be solved on that particular fundamental. Let us say one more example, I'll solve it. Integration minus pi to pi sine of power 4x let's say first solve the simple one, sine cube x dx. How will you solve it? Now again, if you observe, can I see this of this pattern minus a to a fx, and I said it was 2 of fx if fx is even and if fx was odd, it would have been turned out to be 0, isn't it? So is fx odd or even? Fx is odd, so it will simply become 0, right? As sine cube x is odd. That's it. Clear? So one liner you can get the answers if you understand the fundamentals. But if you don't understand the fundamentals, it will become very difficult for you times. Clear? Am I making sense on all the fronts? Right? Sometimes you may be asked questions on double integrals. Double integrals. Right? We should know how to solve double integrals also. Let's say double integrals. You have a function, let's say find I 0 to 1, 0 to 1, x plus y, dx dy. Right? So it's very simple. Differentiate with respect to y first. So you'll have 0 to 1 as it is, xy plus y square by 2. Limits you will put 0 to 1. This is nothing but integration 0 to 1. I'll put the limit of this is dx y. So it is x plus 1 by 2 dx. Then further you will find out f dash or integration, sorry, it will become x square by 2 plus 1 by 2x of 0 and 1, right? So this will become 1 by 2 plus 1 by 2 minus 0. So that will come out to be 1. That's your answer. Clear?